Okay, this is 2008 question 5. This is the moose problem. And when we skip down, and once again, I'm not reading it. Once we skip down, I sit there and go, you know what? I have a table of values. As soon as I see table, might be a chi-squared. I only have one column of observed data. Let's see what they asked for. Researchers who are conducting the study expect the number of moose observed in a habitat to be proportional. So they have expectation is proportional. Since I'm comparing to proportion, this tells me I'm working with a chi-squared. I only have one column of counted data. This, I should have drawn a line. This is my column counted data. This over here is not counted data. So because it's not counted data, it's not part of the matrix. So this right here is my counted data. I only have one column. This makes this a goodness of fit test. Okay, so need to run this test. Conduct an appropriate statistical test to support your conclusion. Assume conditions for inference have been met. That was nice of them. So that means I don't have to worry about the conditions, all right? So HO, the number of moose is proportional to the habitat acreage. And I know sometimes you see proportion and you go, you know what, might be homogeneity. And it might be, you're right about that. But once again, we only have one column. If we have one column, cannot be homogeneity. You have to have multiple columns. The number of moose is not proportional to the habitat acreage. So, and remember, I always say, make these things equal and then not equal. It just makes your life easier. So, formula, observed minus expected, degrees of freedom. Well, we have 1, 2, 3, 4, so 4 minus 1 is 3. Conditions are assumed to be met, and that was a given. I need, if I go to stat edit, I've entered my observed into L1, 25, 22, 30, and 40. That summed up to 117. And there's the proportions. Well, keeping in mind, that's not my expected value. The proportion is not my expected. So I'm going to go second 2 or L2 times 117. That was the total number observed. And there, now I have my observed values. I just write them off to the side just like that. And the graders will be very happy with that. Okay. One thing to notice, we had less than was expected. We had more than it was expected. We had more than it was expected. And here we had less than it were expected. We'll get back to that later, but that's want to make that note. So I'm going to go ahead and run this thing. Stat test, chi-squared, goodness of fit test, L1 and L2. My degrees of freedom, 1, 2, 3, 4, 4 minus 1. All right, calculate. And I end up getting a very large chi-squared of 43. And I end up getting a p-value. And be careful, even though it starts with a 1, it's times 10 to the negative. So this is essentially 0. I've got 8 zeros in there. So our p-value is approximately 0, which is less than alpha. The p-value is near 0. We reject the null. There's sufficient evidence at alpha equal 0.05 to suggest that the moose population is not proportional to the habitat acreage. So there is sufficient evidence to suggest that the researchers are incorrect in their assumption. These ended up being my contributions. So when I calculated this, I got 5.49. When I calculated this, I got 3.29. The nice thing about a goodness of fit is they actually does it for you. And then I have an 8.77 and a 26, which is huge. That's the one that has the largest contribution. So of the two that were positive, this is the one that had the greatest contribution. And I want that part because question 2, or question part B, and of course I set it aside, here it is. So question part B says, relative to the proportion of total acreage, which habitat types did the moose seem to prefer? Explain. Well, here's what we have. Habitat 3 is preferred by the moose. The number of moose in habitats 2 and 3 are higher than expected, indicated the moose preferred those areas. And of those two, habitat 3 contributes 26.13 to the chi-squared statistic, demonstrate that moose prefer habitat 3. Habitats 1 and 4 were not considered because they had fewer moose than was expected. All right, so we only considered the positive. All right, we didn't consider the negative. Here we had 25, we expected 39. Here we had 40, we expected 53. So we're below here. But here we had 22, we expected 12. Here we had 30 and we expected 12. So obviously these, the moose preferred according to this study. All right. Okay, that concludes this one.